This is Mac 1105, Section 1.6, Part 4. And this is all about solving radical equations. It's a pretty straightforward process. You want to isolate the radical on one side, which oftentimes it is already, and then raise both sides to the index of the radical, and then of course be sure to check your answers. And the reason we want to check our answers has to do with the nature of a square root. When you take the square root of a number, like the square root of 9, we get 3. Square root of 9 is 3. This is what's known as a principal square root. So we cannot have the square root of x equals -2. Nor can we take the square root of a negative. So when we check, if we plug back in and we get a negative under the radical sign, that's not okay either. So both of those things can happen when you are solving radical equations. The solving says raise both sides to the index of the radical, and the reason is this. This is a square root. To undo square root, we need to do the opposite, which is square, and we need to square both sides. The square root of 3x plus 18 squared is just 3x plus 18, because the squared and the square root are opposites of each other, and they cancel out. And then we have x squared over on this side. When you see this kind of equation that has x squared in it, your strategy is everything has to be on one side in descending order equal to 0. I like to keep the x squared positive so that it doesn't mess up my sign rule, so I'm going to bring the 3x and the 18 over to this side. And then we're ready to factor. We have x, x. Since the last sign is negative, one is minus, one is plus, and what you are saying to yourself is what two numbers multiply to give you 18 that subtract to give you 3. And it must be this way so that we'll end up with the -3x in the middle. So when you solve these, we get x equal to 6 or -3. So let's go back to the problem and take a look at this from a checking standpoint. That's just the problem written again. And let's put 6 in here for this x and 6 in here for this x and see what happens. 3 times 6 is 18. 18 plus 18 is 36. The square root of 36 is 6, so yes, 6 checks. Now if we put -3 in for this x, you're looking at 3 times -3 is -9, plus 18 is 9. The square root of 9 is 3, but that says it's equal to -3, which is not true, not possible, so the -3 gets tossed out. Our only solution is x equals 6. Very similar problem over here. This is the square root. We're going to square both sides to undo that square root. The square root of 20 minus 8x squared is 20 minus 8x equals x squared. Like the last one, I want to bring these terms over to this side because I want to keep the x squared positive. So this is x squared plus 8x minus 20 equals 0. We're ready to factor. We have x and x in the front. Since the last term is negative, one is minus, one is plus, and we're saying what multiplies to give us 20 that subtracts to give us 8 will be a +10 and a -2. Solve that, gives us x equals 2 and -10. I just recopied the original equation, and to check this, I need to put a 2 in for that x and do that arithmetic. 8 times 2 is 16, 20 minus 16 is 4. The square root of 4 is 2, which is what that says, so the 2 is a keeper. Now, if I put -10 in for each of these x's, watch what happens. -8 times -10 is 80. 80 plus 20 is 100, and we're looking at the square root of 100, which is 10. But over here, it says -10. 10 does not equal -10. Therefore, the -10 is going to get tossed out, and we keep the 2. Those two were pretty easy. We squared both sides and just had to solve the quadratic equation. This one and the one following has a little bit more work to it, and that is, okay, we need to square both sides. Square both sides. We need to square that as the binomial. It is not square the x, square the 3. When you square a binomial, you should write out both binomials and FOIL it up. So x times x is x squared, minus 3x, minus another 3x. -3 times -3 is 9, which gives me x squared minus 6x plus 9, which is what this side simplifies into. On the other side, the square root of x plus 3 squared is x plus 3. Strategy to finish this, we have an x squared, which means everything has to be on one side equal to 0. So I will subtract x from both sides. I will subtract 3 from both sides, which gives me 0 equals x squared minus 7x plus 6, which we need to factor. Because the last sign is positive and the middle sign is negative, these are both negative. And now I'm saying what multiplies to give me 6, that adds to give me 7. And the reason I'm saying add is because these two signs are the same signs sum. So we get 6, we get 1, and we have these two solutions, we think, 1 and 6. So we've got to check, and we check by plugging back into the original equation. This was the square root of x plus 3 equals x minus 3. If I plug 1 right here and 1 right here, 1 plus 3 is 4. Square root of 4 is 2, but 1 minus 3 is negative 2. 2 does not equal negative 2. That means 1 does not work. If you put 6 in for each of these x's, 6 plus 3 is 9. Square root of 9 is 3. And on this side, 6 minus 3 is 3. Therefore, the 6 is our only solution. This one's just a teeny bit different, and that is because we want to have the radical isolated. Remember these directions over here, it says isolate the radical on one side. Well, the first several examples already had the radical isolated on one side. But over here, that radical is not isolated, so we need to move the 8 over to the other side. Now the radical is isolated. 2x plus 19 equals x plus 8. We are ready to square both sides. Square root of 2x plus 19 squared is 2x plus 19. And then we must FOIL this binomial. X plus 8 squared is x plus 8 times x plus 8, which FOILs and simplifies into x squared plus 16x plus 64. So this is x squared plus 16x plus 64. Our strategy, because there's an x squared in the problem, is to get everything over on one side equal to 0. So subtract 2x from both sides, subtract 19 from both sides, gives me 0 equals x squared plus 14x plus 45. And then we are ready to factor x. Both signs are positive, and we're saying what multiplies to give you 45, that adds to give you 14, is 9 and 5. So solve each of these, and we will have x equals negative 9 or negative 5. So to check, we go back to the original equation before we move the 8. 2x plus 19 minus 8 equals x. So we start by plugging in a negative 9 right here and a negative 9 right here. 2 times negative 9 is negative 18, plus 19 is 1. So this is the square root of 1 minus 8. Square root of 1 is 1. Minus 8 is negative 7, which does not equal negative 9. So the negative 9 will be tossed out. Do the same thing with negative 5. So 2 times negative 5 is negative 10, plus 19 is 9. Square root of 9 is 3, minus 8, which equals negative 5, which equals that negative 5, so we do keep the negative 5. Now, I don't want you thinking that we always throw one out. Sometimes we keep 2, sometimes we throw both out. It just depends on the numbers. I just wanted you to have some that you could look at and you could do some checking and realize what needed to be thrown out.